Hello everybody, this is Mr. Carlson, and we're going to look at the homework for Chapter 2. Now the reading assignments are pretty straightforward. These reading assignments here, I believe for Chapter 2 you'll just be able to work through them if you watched the previous video. So I'm going to let you take care of that in the previous video. What we're going to do in this video is look at the study plans for Chapter 2. And unfortunately, Chapter 2 has some of the most irritating problems in the entire class. And you're going to see what I mean, and I might even miss a few of these just because they're very tedious in terms of doing the problems. So here we go. We're just going to do some practice problems from, I believe there's 8 quizzes in Chapter 2. 1, 2, 3, 4, 5, 6, 7, 7 quizzes. So we'll just practice a few problems from each one, and hopefully you'll understand how to do them. Okay, so in this first problem, they give us a frequency table, and they want us to put in the relative frequency. And so remember, in statistics and probability, a lot of the time, they're going to give us a problem, and there's a piece of information that we're missing, and that piece of information is the total. When you're doing something in statistics, always find the total if you're doing a problem like this, because if that can help you avoid test freezes. At least find the total, find n. Remember, n is the variable for the number of people in our sample most of the time. So find that number, and then you can at least be doing something, and then maybe you'll remember what else to do. So let's just add all these numbers up real fast. So 2 plus 15 plus 13 plus 6 plus 2. So 38 total. So I'm going to clear that. Oops. I'm going to clear that. And so to find the percentages, you just do each one divided by the total. So 2 divided by 38 is 0.052. It says round to 2 decimal places. So what I'm going to do is multiply this by 100. Okay, so that's going to be 5.26% to convert that decimal. To a percentage, you multiply by 100. And I'm going to go ahead and copy that answer right there because both of those are 2, so they'd have the same percentage. So Control-C, Control-V is how I copied that. Okay, let's do the next one. 15 divided by our total of 38 times 100. Make sure you're careful with your rounding, so that's 39.47%. And we keep going. 13 divided by 38 is 34.21%. How exciting. And then finally, 6 divided by 38 is 15. Careful on the rounding here. It looks like 15.79%. So hopefully that makes sense. We just find the percentages. All of these percentages should add up to 100. So if you're doing this one on a test, you might add them all up, and it should be almost exactly 100, maybe off by 0.01 or so if you're rounding. But anyway, let me know if you have any questions. Okay, this problem is a little bit irritating. We have this data, and we need to put in the frequency. And so here's our data up here, and you can see we just need to put how many are in each class right down here. So I want to show you, there's one way you can do it, which is just take a screenshot of this and just mark them off as you're doing them, which is fine, but let me show you a better way. Do you see this little icon right here? When we have this icon, it enables us to open our data in various programs. And I'm going to show you how to do some of your homework in Microsoft Excel. Now, if you don't have Excel, you can do most of what I'm going to show you with Google Docs if you use Google Sheets. So in class, I'll show you how to do that. I'm going to use Excel, though, which is maybe the best program ever created. Excel is a wonderful program. So I'm going to click Excel, and oops, sorry about that. You can see that it opened up my file right here in my Downloads folder. So I'm going to click that to open it up. And here we have I'm going to move back into my corner. And so here we have our data. Okay, so I'm going to click Enable Editing. And here's why this is very useful. Don't forget to click that Enable Editing button. That's so we can work with the data. So here's all the data, and watch why we're going to do this. Are you ready? I'm going to highlight the A column by clicking on A. So I've just highlighted the A column by clicking on A, so I've selected all the data in column A. And you see this little button right here with the A and the Z on it. If your screen is big, it will say Sort and Filter. All right, if your screen is smaller, you'll just see the AZ button. So I'm going to click that, and you'll notice it says sort from smallest to largest. So if I click that, what it's now done is it's at least put my data from smallest to biggest, which is nice because now it's going to be a lot easier to count how many are in each one of these categories. See what I'm saying? So 15 to, and be careful here. This is my second time making this video because I made so many mistakes in the last time I recorded this that I felt like I had to do it over again. So please be very careful when you're counting these. I know this is a little bit tedious. So let's shrink this a bit. Okay, so we have 15 to 20.9. I think just 3. And do you see this little bucket icon? I'm going to, let's pick a different color. I'm going to click the bucket icon so I know which cells I've already used. So 15 to 20.9 is 3. Okay, next is 21 to 26.9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hopefully, I think that's 9. And again, I'm just coloring the cells so I know which ones I've already done. Now we have 27 to 32.9, which I believe is 4 of them. (33 to 38.9), which is 2. And that means the last one will have 2 as well. So if you were doing this problem on a test, I would encourage you, I would encourage you to look at this again. Notice we have 20 females in our, sample. So we have 20 values here, 4 times 5, 4 rows, 5 columns is 20. So you might want to just add all these numbers up to see if you have 20. Because if you don't, you know you've done something wrong. So 3 plus 9 is 12, 16, 18, 20. So that's helpful. So that means it's more likely we got it correct. Click check answer, and we did. So fantastic. Okay, let's move on ahead. I'll do that problem in a minute. So same idea here. Here's all of the data. So notice we need to put how many actors are between each one of these ages. Notice you have to click right here, this tiny, I wish I'd make these buttons bigger. They're so small. You have to click this tiny button here to see your data. And then if you want to open it in Excel, you need to click this tiny button right here. Then you can open it in Excel. Click on your data. It'll open it up for you. Click on Enable Editing. Click the A column. And then to select it, and then you can click on this A to Z, sort smallest to largest, and then you can put in your data. All right, so I'm not going to do that again, but you get the idea. Moving on. This question is maybe one of the most annoying in the entire course. So here we have the data for rainfall. Oh, wait, this is the exact same thing as the other problem. Never mind. Again, just open it in Excel and you can count the data and put in the frequency table. Okay, this one. This is one of the most irritating problems in the course. So we need to fill in all of the class boundaries for this problem, and we need to put in the frequency as well. And so here's our data right here. And so let's start by putting in the class widths. So these class widths are easy. So you just look up here. Do you see how our class width is 0.01? That's telling you how far these have to go from each other. And the way you do it is you do 0.01 plus this amount right here, the 2.47, and that's your next lower boundary. So the class width is the distance from lower bound to lower bound. It's not the distance from here to here, it's the distance going down. So here's what I mean. If I pull out my calculator, so we have 2.47, right? And so I'm going to add the class width, 0.01. And so notice I did 2.47 because we don't care about that 0 at the end. So 2.47 plus 0.01, so that's going to be 2.48 is the next class width. Then you just add the 0.01 again, so 2.49, 2.50. I didn't need to type in the 0, but 2.51. So I just notice, just going down, you just add 0.01 to the class width each time. All right, here's where it gets annoying. you need to put one lower than the next class, okay? And you need to go one more decimal place in this one than the next class. So 2.479 would be the appropriate thing to put right here. So 2.479, you notice that that's slightly lower than 2.48. I don't like this very much because I think 2.479 is kind of arbitrary. Like, why not 2.4799 or 999 or 9999? Anyway, they want you to do one more decimal place. So 2.479 is slightly below 2.48. Okay, now once you have this number, and I know that was a little confusing, once you have this number, you just add on the class width again to find the rest of these. So I'm going to grab my calculator. So if I do 2.479 plus our class width 0.01, and so notice that it's 2.489. All right, and so just keep doing that. 2.499, 2.509, and 2.519. So that gives you all of the class boundaries. Now what you would do, and email me, I know that's confusing, email me if you're confused. I know. So now what you do is you go ahead and open this data in Excel again, or you can do it in Google Docs. It's slightly different, but it's the same idea of what we did in Excel. And then you just put however many are there in each frequency. So I'm going to go ahead and just put in a fake answer for the rest of these, because I've already shown you how to count how many are in each category. I just want to check to see that these are correct. So they do give partial credit, which is nice for the study plan. Okay, so you can see that I got all of these correct. So it's just a matter of counting how many are each category, and you can get that right. All right, so that problem is a little bit annoying. Same thing, just count the data. This is the problem that made me redo the video because I messed it up the first time. So don't feel bad if this takes a couple tries. It seems like it's arbitrary how they calculate these limits. I don't understand it. So notice that our class width this time is 0.2. So I just take 123.2. Right? That's my first number, 123.2. And we're just going to add 0.2, which is the class width. And so you see I get 123.4, right? Which gives you the next one. So then it would be add again 123.6, 123.8, and then 124.0. All right, I don't think that 0.0 is necessary. So, we just added the class width over and over again to get the left-hand side. Now, I got this wrong last time because I thought they wanted 123.39. Like, to me, that makes sense. You do one more decimal place like we did in the last problem, but that's not right. They just want 123.3, and I do not understand that at all. I don't understand why that's the answer, because it seems like it's different than what we did in question 3. So, I don't like this problem. So then you just add the class width, 123.5, 123.7. I'm just adding the class width over and over, 123.9, and then 124.9. Wait a minute. Add 0.1, sorry. 124.1. So why they only did one decimal here, whereas they did 2 decimals in the previous one, I don't fully understand. So maybe you can figure it out and you can explain it to me, because to me, it seems a little arbitrary. So we can then click our data. We can open the data in Microsoft Excel, and you can ignore the day. We just need to, in fact, let's actually open this in Excel and see what it looks like. As the screen goes away. All right. So be careful when you're doing this in Excel. You can delete this day column. We don't need it. So I'm just going to click on A, right click, and click delete just to get rid of those cells. Again, all I did there was I right clicked, First I clicked on the A column, then I right-clicked, then I clicked delete to get rid of those cells. I'm also going to get rid of this cell because we don't need it. So we only have our data, which is what we want. I'm going to select it, click this little AZ button, sort smallest to largest, and now you can just start plugging your data in based on the categories and where they fit in. All right, so that's including the endpoints, by the way. So let's just check this first one. I believe these 123s would go in the first category, even though it's on the edge. I hope that's right. I really don't want to do this again. 1, 2, 3. You can tell this homework is a little rough on this one. 1, 2, 3, 4, 5. I'm going to put a 5 here, and we'll see if that's correct. And I'll just put 99 for the rest because you get the idea. So let's check how many I got right. At least they give you 3 tries. That's nice of them. Okay, so that 5 was correct. So I got all the categories correct, and I got the 5 correct. So the 123.3 you do put in this category because that says 123.3. So I guess you're supposed to go to the same decimal as what your data is in. I don't know. That still feels a little arbitrary to me. So again, if you mess this up, don't feel bad. Again, I've taught this a lot, and I messed it up, and that's why I'm recording this video again. So don't feel bad if you mess this up. It's a little bit tedious. And let me know if you have any questions. So that's that. Same thing on this problem. By the way, I have a piece of advice for you. If you're wanting to look at how to do this, click on View an Example, and it'll walk you step by step through how to do it. And so this can be pretty helpful. They tend to be overcomplicated and verbose, but at least you can just click through and see how to do it. There's also Help Me Solve This. I don't recommend clicking Help Me Solve This because they do show you how to go through it, but you have to do all the work yourself. See, you have to do the work before you can move on. And because this homework takes so long, I just recommend doing View an Example because then you can just click through it and you don't have to do it yourself. You don't get credit for the Help Me Solve This. So my recommendation is do View an Example and don't do Help Me Solve This unless you're just a fan of doing extra work. Okay, so we got through that study plan. Let's look at the next one. Thank you. Okay, this one's actually not so bad. So they've done the frequency table for us, thank goodness, so we don't have to do it ourselves. So here we need to identify the lower class limits. That's easy because it's just the lower edges of these classes, of these ranges. So it's literally just 5, 14, oops, I'm sorry, 15, how about? 5, 15, 25, 35, 45, 55, 65. So that's just the left-hand side of all of these ranges. So easy enough. Then they ask for the upper limits. Same idea. It's just we need to do the right edges of the boundaries. So 14, 24, 34, 44, 54, 64, 74. So those are all of the upper limits, just the right-hand side of these ranges. So we'll click check. Easy enough. Identify the class width. Now here people make mistakes. What people do is they do 14 minus 4, or 14 minus 5, I mean. What I meant to say was 14 minus 5, and then they think, oh, it's 9. The class width is 9. No, that's technically not correct. The class width is one lower to the next lower, or one upper to the next upper. So it's actually 15 minus 5. In other words, it's how much these numbers jump every time, both the lower and the upper. So the class width is 10. It's not equal to 9. So just watch out for that one. Identify the class midpoints. The way you calculate the class midpoints is that's the number that's right in the middle of each class. And the way you calculate that is you grab your calculator. And so for the first one, you do 5 plus 14. So you add the two ends of the bound together, 5 plus 14, and then you divide that number by 2. So I went kind of fast. That was 5 plus 14 divided by 2, which was 9.5. So that's how you calculate the first class width, like that. So 5 plus 14 divided by 2. So let's do the next one. Same thing for all of these. Grab the calculator again. So the next one would be 15, which is there. 15 plus 24, hit equals, and then do divided by 2. And it's important to hit equals because otherwise, if you do 15 plus 24 divided by 2 in your calculator, so if you do this, 15 plus 24 divided by 2, it's going to give you the wrong answer. Because of the order of operations, it's doing just 24 divided by 2 instead of all of 15 plus 24 divided by 2. So the correct way to do this in your calculator without getting it wrong is 15 plus 24, then hit enter or equals, then divide it by 2. So that gives us 19.5. By the way, if you heard that little noise, that's students asking questions. And so I will answer that when I'm done recording. So I hope you ask questions too with Ask My Instructor if you are stuck. So we've got 9.5 and 19.5, and you might notice that we're going, like before, when we did these, you notice we're going up by the class width each time. So to save some time, I'm just going to add 10 every time, and then we'll be done. All right, so check the answer. And we got it correct. So save a little time when you notice that it goes up by the same amount each time. Okay, identify the class boundaries. All right, this is a little annoying. The class boundaries is what separates one class from another class. And so the formula is the same as what we just did, except what you do is you do one upper class, 14, with the next lower boundary. So the upper boundary with the lower boundary, and the formula is the same. But there's one trick to this, which I'll show you. So watch this. So first we're going to calculate that. So it's the upper of 14. Let me clear the calculator first. So it's the upper of 14 plus the next one, 15. So those are the two edges. Press equals, then press divided by 2. So there's your first boundary. Notice that's right in between 14 and 15. Do you see that? But here's the trick. I'm going to put that in as the second answer, right? That seems weird. Just bear with me. I'm putting that in as the second answer, okay? So now let's do the next one. Let's do 24 and 25. So the one lower boundary and then the next upper. All right, so that's 24 plus 25 equals, divided by 2 is equals, and so I get 24.5. I'm going to put that as the third answer, okay? Now, you'll notice that this is going up by 10 every time, just like all of our others. It's going by the class boundary, so I'm just going to add 10. Oops, that's actually, shoot, let's do it correctly. So I'm going to add 10, which would be 34.5. 44.5, 54.5, 64.5, and 74.5. Now, how do you get this first one? Because remember, I put the first answer in second. You actually need to subtract 10 to get this one. So the reason, this is just how this problem works. You need to go one below the 5. You see that? One below the 5. And then the one on the top should go beyond the top one. So notice we have 74.5, which is above 74, and we have 4.5, which is below 5. So that's why when I found this first answer, 14 plus 15 divided by 2, I put that in as the second one because we actually need to subtract the class width to go one lower than the data. And we also have to go one higher than the data. And it took me like a half hour to figure this out the first time I taught this class. So hopefully that saves you some time. Please email me if you're stuck on this, because again, this is not my favorite problem. Statistics is far more interesting than trying to do all the nitty-gritty details of these frequency distributions. Okay, identify the number of individuals in the summary. That's not too bad. To do that, we just add up all of our frequencies. So grab the calculator. 31 plus 35 plus 15 plus 2 plus 4 plus 1 plus 2 is 90. So I just added up all my numbers to get 90. Got it correct. Please be done. Hooray, we're done. Sorry, headphone users. So that's how you do this problem. I think the trickiest thing to get correct is these class boundaries. Just follow it how I showed you, and you should get it correct. And I know that's a multi-part question, so please email me if you have any questions. And I'll let you figure out the multiple choice. All right, so that's the second quiz. I think those are the two hardest quizzes. All the multiple choice questions I answered in the other video, so I'll let you figure that out. So on this one, they want the total number in the summary, so that just adds them all together. Let's see, 28, 31, 41 plus 7 is 48. Okay, so the question asks, is it possible to identify the exact values of all the original service times? So this is a fast food restaurant. Is it possible to identify the exact values of the original service time? I'm going to say no, because they only tell us inside the limits. So the data values can take on any value between the class limits inclusive. That sounds like a good answer. No, the frequency distribution tells us nothing about the data values that fall below the lower or above the higher. That's not a good answer, because if that was the case, we would just add more rows. So if there was data below or data above, we would just add more rows. So I think the right answer is B, but let's embarrass ourselves by getting it wrong. Oh, we got it. Okay, so the answer is B. All right. So the whole point of a frequency table is you have ranges, so you don't have the exact values, which is what I think that's trying to say. Now on this one, they're going to say, identify some flaws with the results. So heights of adult males are known to have a normal distribution. That would be a bell curve. Normal distribution, remember, is that all-important bell curve. A researcher claims to have randomly selected adult males and measured their heights with this relative frequency. So the first major problem I can see immediately, and this is something you should always keep your eye out for, is if you look at these percentages, you'll notice that they'll add up to more than 100%. So obviously this person's made a mistake, because you can't have more than 100% of your data. So that's problem number one. So let's see if that's one of the choices. The classes do not allow for the possibility that you could be between 144 and 145 or 169 and 159. That's not true, because that's what the midpoint is for, and so that's what separates the two. If you're below the midpoint, you go into the lower one. If you're above it, you go into the next one. All of the relative frequencies are different. If they are from a normal distribution, they should be exactly the same. That's not true, because that's true for a uniform distribution, maybe, but not a normal. The relative frequencies were recorded as percents instead of counts. That feels like it could be true, but I don't know if that's true or not. What matters is that they add up to more than 100%. All of the frequencies appear to be roughly the same, sort of. If they are from a normal distribution, they should start low, reach a maximum, and then increase. I like that answer. It's not a great answer, but it's better than this one. If it was a bell curve, we should have low, medium, high, medium, low. You know, like the bell curve with the tails. So I think D is probably okay. The classes do not allow the possibility that an adult could be less than 130 or greater than 204. I suppose, but that doesn't feel right to me. Again, if there were data that was less than 130 or more than 204, you would just add that to your table, you know. So we'll assume that they did that. This was the answer I was looking for. So I had to scroll to see the right answer. That was why I was getting confused. So the sum of all of the frequencies is 121%, but it should be 100%, maybe with a small round off error. So hopefully, I think those are the two answers. Hopefully that's right. Okay. So you see how I kind of just worked through that. Keep in mind that I've done these problems many, many, many times. So it's okay if you miss this the first time. The goal is just to try to understand these frequency tables. So that's 2.1. That's the next quiz. All right, so we're done with 2.1. I think that's the hardest section, 2.1. Let's quickly go through 2.2. These I cover in the other video. They're not too difficult. If you miss it the first time, it's okay. Let's do this one, number 4. How many team members are included in the histogram? So here's our histogram. Just count the bar graphs, right? So here's 3. So this bar has 3 individuals, because remember, in a histogram, this is the frequency over here. So we have 3 plus 2 is 5, plus 5 is 10, plus 1 is 11, plus 3 is 14, plus 3 is 17, plus 5 is 22, hopefully. So just count the bar graph, not too hard. Let me know if you have questions. On question 5, they want to know the class width. Okay, so looking at the histogram, what's the class width? That's the upper one to the lower one. All right, so 120 to 110. Okay, so that has a class width of 10. It's the one class to the next. It's easier to see on the histogram, I think, than it is in the frequency table. What are the approximate lower and upper limits of the first class? See, here's where it's going to be wrong. I bet you they're looking for 110 and 119. All right, so you see how it starts at 110, right? And it looks like it's going to 120, but remember, 120 is technically the start of the next class. It's not the upper of the it's not the upper. So let's see if that's right. I could be wrong here, but let's see. See, to me, that's just dumb. That's really, I don't like that. Like, I understand technically that's correct, but to me, that's really splitting hairs. So you would be forgiven if you put in 110 and 120, because the bar goes from 110 to 120, right? But that's technically not correct. It goes from 110 to one below the next bar, and so it's 119. So if you can sense the sarcasm and irritation in my voice, it's because I think that's unnecessarily complex. The midpoint would be at 119.5. So anything below 119.5 would be counted in this first bar graph, and 120.5 or more would be, or 119.5 or more would be included in this upper bar graph. So anyway, kind of annoying. So on this one, you need to match the bell curve to the frequency table. So just look at the frequency and see which bars match. I'll let you figure that one out. By the way, looking at this, all 3 of these look like decent normal distributions. So you just have to see which one matches. Here, we need to choose the correct bar histogram again, and the data is this blue button, so click the blue button. Oh my goodness gracious, how on earth are you going to do this? I guess you're going to download the data in Excel. So let's do that again. And if you need some help on how to do this with Google Docs, I will consider it. I'm making a video real quickly on how to do this. So I'm going to delete this top one because it's not needed. Select the A column, sort smallest to largest, like we've done 100 times. Okay, we'll close this. Luckily, the class limits are all the same. So the first one goes from 69.5 to 109.5. So that's this many. So 69.5 to 109.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there should be 11 in the first class. So that eliminates A because A only has 5. Eliminates B because B only has 5. So it's either C or D. Okay. So then I would move to the second class. That looks to be the same. So maybe I would jump to the third class. That looks to be the same. So it's going to be the fifth or the fourth class. That's the difference you can see on this right tail. So let's go ahead and do it real fast. So I'm going to look at the fifth, the last class. So that is from 229.5 to 269.5. So 229, so those are not included. That's not included. So it looks to me that 229 or bigger is only 4 values. So that's going to be D, because this one is saying there's 20 values in the last one, but we just saw that there's only 4. So it looks like D is going to be the answer on that one. So there's the distribution. It looks like a normal distribution with a long right tail. So I would say it appears to have a longer right tail, so that means it's skewed to the right, I think. Okay, so remember being on the sled, if you have a long sled ride to the right, that means it's a positive skew, a right skew, and we have some outliers up here, but the majority of our data is down here. So hopefully that makes sense. I talk more about that in the previous video. So here's just some more matching. You can do this in Excel, but it's a little complicated, so I'm not going to show you that. If there's people really struggling with this, I'll show you how to do it in Excel, but I think I'll hold off for now. So just more matching. Some fill in the blanks I cover in the previous video. Okay, so I think that's good for that quiz. Let's push ahead. So does this appear to be normal? I answered this question in the previous video. This is a normal quintile plot, which is a very special test that tells you if something is a bell curve. If your data is a bell curve, and here's our data, it's impossible to tell just by looking at it. You do this statistical test called a normal quintile plot, and if it's a bell curve, then the dots should fall on the red line. Or there should be they should be pretty close to following the red line, and there should not be any other patterns. So here you can see that they're kind of in a line, but that line doesn't match the red line. So this is not normal data. This data is not a bell curve. It's some other thing. Who knows what it is, but it's not a bell curve. So I guess the answer is D. The distribution is not normal. The points are not reasonably close to a straight line. So that test is pretty complicated, and in a more advanced statistics class, you would learn more about how it works. Now, there's an error, so I didn't even count it. Fantastic. Thank you, MyLabs Plus. This is why I do empathize with you when you have MyLabs Plus problems, by the way. I understand that this can be very frustrating. All right, let me know if you have any questions on that, and we'll quickly look at the last set of quizzes. Okay, so this is just a stem and leaf plot. It's just a matter of matching. So we go from so we have 60 to 100, so 6 to 10 on all of them. This is just a matter of elimination. So let's see. All of them have 100, so that doesn't help. There is no 50 value, so that... okay, so we have 68. So 68, so that eliminates D. Let's see, 3, 5, 3, 6. We have 73, 75. So that eliminates C because C has 76. So it's either A or B. It looks like the difference is right here. That's 6799. That's 6996. Well, that's wrong immediately because they went big and then went small again. So I think it's A automatically because it went small, big, big, small. But let's just make sure that it's 86, 87, 89, 89. So 289s, 87, 86. So A is the correct stem plot. I know that was kind of quick, but if you weren't sure on it, just review, rewind the video, or ask me a question. Same thing here. You can just look at the data and figure out which one of these is the correct stem plot by just matching the data. So we will leave that and do the last quiz, determine when a graph is deceptive. So this graph is clearly deceptive because as I mentioned in the previous video, the y-axis doesn't start at 0, so it looks like there's a much bigger gap than there actually is in real life. So it creates the impression that men have higher salaries that are twice women's salaries. That's a pretty provocative question. I would have picked something less. Well, anyway. Okay. So the point of the story is you need to have your bar graph start at 0. That's all you need to know. I think you can answer that from the previous video, and you can answer that from the previous video. So good luck on these study plans. I think the 2.1 sections are the most difficult. It's okay if it takes more than one attempt. Please email me if you have questions. I would be happy to answer them. And good luck on your homework. And thank you so much. I hope you're enjoying the class, and hopefully you can get through these homeworks pretty quick. All right, talk to you later. Bye-bye.